multiprocessing.Pool slower than just using ordinary functions. This question is about how to make multiprocessing.Pool run code faster. I finally solved it, and the final solution can be found at the bottom of the post. Original question. I'm trying to use Python to compare a word with many other words in a list and retrieve a list of the most similar ones. To do that I am using the difflib.get_close_matches function. I'm on a relatively new and powerful Windows 7 laptop computer, with Python 2.6.5. What I want is to speed up the comparison process because my comparison list of words is very long and I have to repeat the comparison process several times. When I heard about the multiprocessing module, it seemed logical that if the comparison could be broken up into worker tasks and run simultaneously, and thus making use of machine power in exchange for faster speed, my comparison task would finish faster. However, even after having tried many different ways, and used methods that have been shown in the docs and suggested in forum posts, the pool method just seems to be incredibly slow, much slower than just running the original get_close_matches function on the entire list at once. I would like help understanding why pool is being so slow and if I am using it correctly. I'm only using the string comparison scenario as an example because that is the most recent example I could think of where I was unable to understand or get multiprocessing to work for rather than against me. Below is just an example code from the difflib scenario showing the time differences between the ordinary and the pooled methods. The word to be found is hello, and the list of words in which to find close matches is a 1 million long list of 5 randomly joined characters, only for illustration purposes. I use 3 processor cores and the map function with a chunk size of 100, list items to be processed per worker I think. I also tried chunk sizes of 1000 and 10,000 but there was no real difference. Notice that in both methods I start the timer right before calling on my function and end it right after having looped through the results. As you can see below, the timing results are clearly in favor of the original non-pool method. The pool method is almost 4 times slower than the original method. Is there something I am missing here, or maybe misunderstanding about how the pooling/multiprocessing works? I do suspect that part of the problem here could be that the map function returns none and so adds thousands of unnecessary items to the results list even though I only want actual matches to be returned to the results and have written it as such in the function. From what I understand, that is just how map works. I have heard about some other functions like filter that only collects non-false results, but I don't think that multiprocessing/pool supports the filter method. Are there any other functions besides map/imap in the multiprocessing module that could help me out in only returning what my function returns? Apply function is more for giving multiple arguments as I understand it. I know there's also the imap function, which I tried but without any time improvements. The reason being the same reason why I have had problems understanding what's so great about the itertools module, supposedly lightning fast, which I've noticed is true for calling the function, but in my experience and from what I've read, that's because calling the function doesn't actually do any calculations, so when it's time to iterate through the results to collect and analyze them, without which there would be no point in calling the function, it takes just as much or sometimes more time than just using the normal version of the function straight up. But I suppose that's for another post. Anyway, excited to see if someone can nudge me in the right direction here, and really appreciate any help on this. I'm more interested in understanding multiprocessing in general than to get this example to work, though it would be useful with some example solution code suggestions to aid in my understanding. The answer seems like the slowdown had to do with the slow startup time of additional processes. I couldn't get the pool function to be fast enough. My final solution to make it faster was to manually split the workload list, use multiple process instead of pool, and return the solutions in a queue. But I wonder if maybe the most crucial change might have been splitting the workload in terms of the main word to look for rather than the words to compare with, perhaps because the difflib search function is already so fast. Here is the new code running 5 processes at the same time, and turned out about x10 faster than running a simple code, 6 seconds versus 55 seconds. Very useful for fast fuzzy lookups, on top of how fast difflib already is.
My best guess is inter-process communication, IPC, overhead. In the single process instance, the single process has the word list. When delegating to various other processes, the main process needs to constantly shuttle sections of the list to other processes. Thus, it follows that a better approach might be to spin off n processes, each of which is responsible for loading/generating 1/n segment of the list and checking if the word is in that part of the list. I'm not sure how to do that with Python's multiprocessing library, though.
These problems usually boil down to the following. The function you are trying to parallelize doesn't require enough CPU resources, i.e. CPU time, to rationalize parallelization. Sure, when you parallelize with multiprocessing.Pool, you theoretically, but not practically, could get an 8x speed up. However, keep in mind that this isn't free, you gain this parallelization at the expense of the following overhead. Creating a task for every chunk, of chunk size, in your eater pass to pool.mapf, eater, for each task. Serialize the task, and the task's return value, think, pickle.dumps, deserialize the task, and the task's return value, think, pickle.loads, waste significant time waiting for locks on shared memory queues, while worker processes and parent processes get input from / to these queues. One-time cost of calls to os.fort, for each worker process, which is expensive. In essence, when using Pool you want high CPU resource requirements, low data footprint passed to each function call, reasonably long eater to justify the one-time cost of 3 above. For a more in-depth exploration, this post and link talk walk through how large data being passed to pool.map and friends gets you into trouble. Raymond Hettinger also talks about proper use of Python's concurrency here.
I experienced something similar with the pool on a different problem. I'm not sure of the actual cause at this point. The answer edit by Kareem Burkad is the same solution that worked for me. After switching to a process and queue system, I was able to see speedups in line with the number of cores for a machine. Here's an example.
Pool.map is slower because it takes time to start the processes and then transfer the necessary memory from one to all processes, as Multimedia Mike said. I have gone through the similar problem and I switched to multiprocessing.process. But multiprocessing.process takes more time to start the processes than Pool.map. Solution: create the processes in advance and keep the static data into the processes. Use queues to pass data to processes. Also use queues to receive the result from the processes. This way I managed to search for the best match from 1 million face features in 3 seconds on Core i5-8265U processor laptop with Windows. Code: multiprocess_q_matcher.py. Then use this module where you need advanced startup code for Flask. Pass jobs to processes on demand on any request endpoint. Any suggestions and improvements in this code?